Welcome back, everybody. I hope you enjoyed the break. I hope you are enjoying the places we designed especially for networking, and especially I hope you have done real networking today. So it is my pleasure to present you our next guest, Nicolas Frankel, who is a developer advocate at Hazelcast. He has 15 plus years of experience in this field. He is consultant for many customers from different areas like telecom, banking, insurance, large retail, and public sector. He's working mainly in Java, Java EE, and Spring technologies, but also he focuses interest in rich internet application, testing, that's my subject as well, CI/CD, and DevOps. Apart from his current job, he is a teacher, a book author, and in your warmest applauses, Mr. Nicolas Frankel.
So now I hope you know every partner and sponsor of the conference. So I'm very happy to be here. This is my first time at GoTech World. I'm Nicolas Frankel. As the nice gentleman says, I've done some stuff in my life. And last year I started being a developer advocate. I work for a company called Hazelcast. Who knows about Hazelcast? Few people. Okay, great. So what I will be showing into this presentation is how you can use our main product, our first product called like IMDG, in-memory data store, to help you with performance in your application. But basically now we have another offering that's called Jet, Hazelcast Jet, and that allows you to do data streaming. And it's based on Hazelcast IMDG. So listen. Microservices. Who does microservices here? Yeah, everybody does microservices, right? It's so hype, it's so cool. If you want your next job, you must do microservices. Otherwise, you are legacy, you are old, you have white hair, and you are not employed anymore. If I ask the question, is probably because you all follow those principles, right? All those principles, they are on Martin Fowler's website. So basically, if you do microservices, you implement everything, right? Who here implements everything? So probably nobody. In general, there is a problem because here, you might have this stuff, but in general, you have probably projects. So you have a start date, more importantly, you have an end date. And if you have an end date, you have a project. And you have a project, you know how it works. There is a schedule, and at the end, well, some stuff gets skipped, like quality or whatever. So I believe that most people don't do microservices. So what you probably do like web services anyway. And one of the benefits of microservices, or let's say to split your monolith, is scalability. So basically, instead of having like one big piece, and if you need to scale, you must replicate this one big piece, well, you have small pieces, and you only replicate the pieces that you need. This is one of the big benefits of microservices. And of course, as I've been told, I've been an architect. So we love UML diagrams. Who here is an architect? Yeah, you love UML diagrams as well. Yeah, everybody does. And that's what architects do. Like we write UML diagrams, and then we send them to the developers, telling them, hey, the rest is just implementation details. But who can spot the difference between those two diagrams? Nobody? Come on. On the left, it's an API call, and on the right, it's a REST call. It's obvious. It's obvious. And that the problem with microservices is that we are trying to convince people that well, it's just the same stuff as an API call, but it's not. And once you start doing distributed systems, yes, you might have scalability. You might, but actually you lose performance. Because between a REST call and an API call, it's 1 or 2 orders of magnitude slower. So yes, it scales, but it's less performant. And perhaps you know about those fallacies of distributed computing, right? The network is reliable, no latency, the topology doesn't change, never. So our previous, remember, on the left API call, on the right REST call. In general, it should probably be something like that. And I've only represented 3 layers, but there might be many, many more. And of course, here it's easy, it's fire and forget. But probably it's more like that. So there is a trade-off. Either we want very, very fast stuff, and then it involves caching, or we want up-to-date stuff, and it's slow. So I'm not here to tell you there is a magical solution to every problem and just use my solution and poof, everything will be fine. I'm just telling you about there is like an option and it involves a trade-off. And of course, I said the magic word, caching. So you know there are 2 hard things in computer science, like cache invalidation, naming things, and off-by-1 errors. That's supposed to be a joke, huh? Just that we... So whoever here implemented caching? Okay? Now keep your hands in the air, please. And keep your hand in the air if you used a custom implementation. You know where I'm going to, huh? So caching, hey, guys, we know how to do caching. Everybody does. So that's what you did, right? A hash map. A hash map is just the basics of caching. Everybody loves hash maps. I mean, we know it's performant. We know how it works. And then you must say, oh, I must remove stuff from the cache. Huh. So I will build my own cache invalidation so that I can like purge the cache. And then you say, I don't want to do it like explicitly, so I want that the objects, they remove themselves automatically. Oh, that's the time to leave. And now your simple hash map is not that simple anymore because caching offer a lot, caching products, they offer a lot of features that are mostly required. And we have this concept of the in-memory data grid. So an in-memory data grid is just a distributed object store. And in order for you to reason about it, you can think that it's a distributed hash map. It's likewise. And in microservices, we have 3 core themes where basically we can use caching. The first is database access, because whatever you do, probably at some point you have a database. It can be a NoSQL data store, or it can be a SQL data store, but you have this stuff. Also, as I mentioned, and that was the beginning of the talk, microservices, like REST calls, they are super slow in general compared to an API call. So you might want to speed off your result by just caching the results. And finally, I'm sorry, but we are not living in a stateless world. Most of us still use sessions at some point. We must store data that is related to the user. It can be in the database, but it's very inefficient. So basically, you probably put stuff in like session in memory, but you have multiple nodes. So every node has session data. And this is hard to replicate by default. So first off, Hibernate. Who here uses or used Hibernate? Yeah, most people do, because, I mean, if you are old, probably you use Hibernate, and if you work for old people, you probably also use Hibernate, whether directly or through GPA. So I think that's one of the most widespread now object relational mapper. And you might know that in Hibernate, you actually, you have two caches already. So one is called the level 1 cache, and it's by default. And every time you create a session object, then if you reuse the same session object, then the result will be stored into the session object. If you are using a web app, of course, every time you create a new request, you will create a new session. So that this cache is basically only used for one single transaction. And then you have the level 2 cache, which by default is not enabled. You must enable it explicitly. There are several providers out of the box, multiple integration. But then it's across the application, so it's on the node itself. And I mean, it's a stupid cache, so this is how the cache works. I probably don't tell you anything new. Either it doesn't contain the key, so it gets to the data store, it stores the results in the cache, and it gives it back, or if it already has the result, then it gives it back. And it writes by doing the opposite. It just create or update the entity and create or update the cache value. So let's do some demo. Because I like demos, because otherwise it's just slideware, which is not very interesting. Who loves slideware here? Nobody? I've created a Spring Boot application with start.spring.io. Everybody is more or less familiar with Spring Boot? Yeah, great. If not, raise your hand. I mean, you can ask questions. It's not an issue. So I have not that many dependencies. I have the Spring Data Starter Data GPA because I'm using GPA. I'm not using Hibernate directly. I've started web to make REST calls, and I'm using Hazelcast and Hazelcast integration. And because I'm super lazy, I didn't spin up any new database. I'm just doing the embedded H2 database, which is good enough for my usage. So controller does nothing. It's just calls the repository. And the repository does not much because I'm using Spring Data GPA, which basically creates the implementation at runtime, which means that because I'm super lazy, I'm super happy, and I just have a working application in a matter of minutes. So where the magic lies? The magic lies in my configuration. So here, I'm configuring Hibernate to use a cache. And I'm using Hazelcast as a cache, of course. Use second level cache true, use query cache true, and then you just say, hey, use this class for a region factory, and which instance, because you can have different cache instance, it's a default instance name. And then we configure Hazelcast itself. I added stuff, but basically you don't need that much if you don't need to. And of course, who loves XML here? You love XML. I love XML as well. I'm always very surprised when people tell me that YAML is good and XML is bad, because a lot of people love YAML. Just want to kill myself every time I use YAML. And XML has a lot of bad stuff, but basically, at least you have a grammar. You cannot do that much. You have let's say compile time safety, at least more than with YAML. And here we have this XML configuration, but if you don't use XML, then you can use Java configuration. That's fine too. So basically, I just replaced the XML with just Java code, which is even more type safe than XML. So how does it work? We can start the application. Amazing, it starts, so my demo is not that bad. And we can see here in the console that basically it took a bit of time to start because I'm using Hazelcast IMDG as an embedded. So basically every application as I start, it will start an Hazelcast instance. And it will try to join the cluster of other Hazelcast instances if it can. It's one mode, it's called the embedded mode. It's super easy if you just want to play with it. Of course, it's not the only mode. We also have a server mode, so basically then you can scale it independently. But everything is available. And the good thing with the server mode is you can use it with different client technologies. And also what I did here is I enabled the statistics from Hibernate, so basically right now we have nothing. And I will start like trying to get entities, and now I must find the terminal, which is here, and I will clear it because I don't want to see my magic. So I will call like here, I have like 3 stupid entities, I can show it to you, like amazing. It's just to have data. And for the statistics, we can see here that we put something in the cache, in the level 2 cache. And of course, since it was not there in the first place, then it's a cache miss. And if we do it again, whoops, sorry. Normally, it's a hit. And you've got that out of the box with just a few lines of configuration and 2 new dependencies in your POM, which I believe is like great return over investment. You didn't need everything. And of course, at that time, you can like configure the time to live, you can configure your eviction strategy, you can configure everything. More importantly, your cache is bounded now. Well, you can have it unbounded, just like your normal hash map, but you shouldn't. So easy peasy. You have an alternative. Right now we are using like Hibernate and GPA and the database, and we only like talk to the database, and Hazelcast is just like a layer that is in between and just acts as a proxy. But perhaps what you want is you want to interact with Hazelcast IMDG only, because again, it's in memory, so it's very, very fast. And what you can do is you can have listeners, so when you like update or create or delete entities, then asynchronously you execute the same operation on the database. So in that case, it's again a trade-off. You are trading off like resiliency, data persistence for performance. Depending on your use case, that might be an alternative. I've worked in e-commerce, and here is a sample like e-commerce architecture where you have really have a microservice architecture, and every feature that you normally have in an e-commerce shop, then you put a service around it. And some of those services actually could benefit from cache. But not all of them benefit from cache. And very importantly, even if some of them benefit from caching, you don't want to have the same caching configuration for every one of them. So if you want to make HTTP calls, and if you want to have caching, you can do it manually. Like the process for Hibernate, you can do, hey, I will check for the entity in the cache, and if it's not there, I will make the service call, and when I get it, I put it in the cache, and I mean, it's super boring. It's not very interesting, and you have other stuff to do. So there is a Java API for that already. Who knows about Jcache? Okay, not many people. Great. Then you are here in the right room. So Jcache is a specification, one of the longest running in the GCP. And you have one specification, and you can have multiple implementation. And the good thing, if you are using Spring and Spring Boot, then it's already integrated with Spring Boot. Demo time. You thought my demo was wrong because it was red, but it just took time to compile. So now I created a new controller. And this new controller is pretty stupid. It just calls the first controller through a service. So there is this service. And the good thing with this service is this annotation, cacheable. And cacheable is actually the Spring implementation that relies on Jcache. So if I can find the POM here, I have nothing else. And if I check the application, I have nothing else. It's just the same. So now what I will do is I will use another endpoint, this proxy controller, which is R, up here. Oh, I must restart the application. Sorry for that. I hope it's that, otherwise I'm in trouble. And now, if I do it, yes. Always the demo syndrome. When you do a demo, there is a high chance it will fail, even for stupid stuff like that. I don't know why. Now, how can we check that actually the cache is used? Because we have no clue, right? So what we can do is we can spin off our management center. So basically, we have a management center. So we have like a GUI for Hazelcast. This is not open source at the moment. Sorry for that. But we are working on it. So basically, you will please allow me that to just show it to you, because in the coming time, it might work for you. No, not that, not that. I don't want that. I want that. No. No. It's not going to be fun. I told you, every time you do a demo, there is a slight chance it won't work. Guess what? I forgot my password. Well, this is very stupid, so perhaps I mistype it, and since it's my demo, my password is the following. Or not. No. So you should believe me, it works. Who doesn't believe me? You are good engineers, but you are not good attendees. I will show it afterwards. That's uncomfortable, but I will show it afterwards. So we have seen Hibernate. We have seen HTTP calls, which basically can be anything. It's just an annotation. And the third scope is session data. This is a very, very simplified diagram of what generally runs in production. You have your user, and of course, it doesn't access your application server directly. There is a proxy in front of it that tries to do a lot of stuff, mainly load balancing. And the problem with load balancing is the first time you use the load balancer, it will get you on one node, and then you create your session there, and you store stuff in memory there. Now, if the load balancer afterwards gets you to one other node, then you have lost everything, which is not what you want in general, especially if you work in e-commerce and you want to handle the basket. So there is this concept called sticky sessions. Sticky sessions are great because every time you go to the load balancer, once it redirected you to one node, then it will always redirect you to the same node. Problem solved. However, we are working in IT, and we know that it's not if shit happens, it's when shit happens. So at some point, your node will go down, for sure. For sure, it will go down. So in order to keep this data, we must have some kind of replication. And the problem is there are no standards for that. I don't know of any standards because they are application server, but it's not covered by the Java EE specifications. So perhaps it will be covered by the Jakarta EE specification, and most probably not. So we have Hazelcast, great. And Hazelcast allow you to do this kind of replication. And there are several integration points possible. So depending on your level of familiarity, you can use filters like stupid plain servlet filters. You can use Spring Session. If you are already using Spring Session, then you can just replace the implementation of Spring Session with Hazelcast. You can have like direct integration with either Tomcat or JT. And it's a demo time. So now what I will do is I will directly... I've created like a Docker Compose file. And I will have one load balancer. I will have two Tomcat nodes. And I will have the management setter that I forgot the password of, but here normally should work. And the proxy configuration is just a simple, stupid round robin. So every time, it redirects me to a new node. So no sticky sessions. Every time, it's a new node. And I have this like session data controller. And basically, every time I call this endpoint, then it will get hold of the session. And it will store like the session ID, and it will increment the count. So normally, because of this run robin, normally I should like skip every time. I should like go on 1, and then 1, and then 2, and then 2. But because of replication, if what I told you is right, then it should be 1, 2, 3 normally. So let's kill it, and let's try it here. Okay? Not yet. No. Yes. So this is my session ID, and this is my first request, so I get count 1, which is normal. Now, if I have no session replication, it should redirect me to the other node, and I should also have count 1. However, I have count 2, which means that the data is replicated between the nodes. And then I have 3, 4, well, you understood the concept. And now what I can do is I can check if it works this time. I can check the management center, and I hope now, no, please, don't do that to me. That's not fun. That's not fun at all, and perhaps I understood why, because I'm a stupid idiot. Or not. Local hosts. Now, finally, sorry, I forgot the URL. I always use, I remember. I remember the password now. It's not password 74. Oh my God. So here you can see that you've got the two members. Because I'm running Hazelcast in embedded nodes, I have 2 Tomcats and I have 2 instances of Hazelcast. And here we can see that we have this database because we are using the database. And we've got this empty session map. And here we've got one single session. And perhaps we can see that we can search through the map. And yes, here is our session. Of course, it's serialized, but here is our session. So what we could try is we could try to remove the cookie. So with no cookie, I will get another cookie. So I will have another session that is created. And here, I should have 2. So let's try to remove the cookie. And this is this one. Remove, remove, up. So normally, I should be reset to 1. Yes, I'm reset to 1. So I have a new session object, which works the same way. And normally here, at some point, it should tell me I have 2 entries. Yes, I have 2 entries. And here you can manage everything. You can see, you can manage, you can do everything that you need. Also, what I wanted to show you is, like here you have like the entries, here you have the gets, here you have the puts. So if you implement your own cache as a hash map, you have trouble like monitoring your cache. Here, normally, it makes it easy to reason about your cache, what happens if you have cache misses, if you have cache hits, why there are not enough hits, and just worst case scenario, you can browse through your cache and see what happens. I forgot that. So, takeaways for this talk. If you do microservices, you should really remember very hard that being scalable and being performant is not the same. If you are doing microservices to be performant, you are wrong. Actually, you will lose performance. You will take a huge performance hit if you migrate your monolith to a microservice architecture. The thing that microservices allow you to is actually to scale. So if you start like having performance bottlenecks and you have enough money and you want to like buy new stuff in the cloud, then it starts making sense. But it's only at that point. Caching will help, of course, because then you take the data like in memory, which is like super, super fast compared to a database, or even faster if compared to a HTTP call. However, there is a trade-off involved, meaning that you won't have the right data. Depending on your use case, it might be a good idea or it might be a wrong idea. Like, if you have pricing, is it a good idea to have wrong data? Who says yes? Who says no? Who says it depends? It depends. Actually, if you have done any e-commerce, you want to sell at, in general, any cost. Even if you lose a bit of money, you want to sell, to sell, to sell, to sell, to sell. Of course, stale data doesn't mean that you take the price from yesterday, but it might be an acceptable trade-off to cache the prices for 15 minutes, or perhaps 2 hours, you don't know. It's not up to you to decide, it's up to the business in that case, because they know how much they want to sell. Hazelcast IMDG helps you with caching at several integration points, so if you have database access, you might accept to have like caching, and then we make database access faster. If you do services calls, then also we make that faster. And of course, because we are not living in a stateless world, unfortunately, because you want to store data in the session of your user sometimes, then we also help with that. So thank you for your attention. You can read my blog. You can follow me on Twitter, though I've heard that it's not super popular in Romania. But anyway, I will still be happy, and my employer will be happy with me if you follow me on Twitter, of course. And more importantly, if you want to play with my repo, and then you can like copy it and clone it on GitHub, or start it, or fork it, whatever, and make it better so that the next presentation will be even better. So I thank you a lot for your attention, and we have some time for questions. Yes, already a question. That's good.
Hi, thank you for bringing us news about Hazelcast. That data management center is good news. I've tried in the past to play with Hazelcast as a startup for avoiding using Kafka.
Okay.
I thought that Kafka is hard to install, to configure, and I want something fast and easy to prove on proof of concept. Was that a good approach to address Hazelcast as a Kafka replacement in proof of concept?
If you really want streaming, then it's not Hazelcast, IMDG, it's Hazelcast Jet that you want.
No, it was about messaging. It was just a messaging.
Then it's Hazelcast Jet. Like, you must think as Hazelcast as a distributed hash map. And a hash map is not that great for messaging. You can always tweak it. We are engineers. We can always tweak something to make it work as some other thing, but it's not the right use case. So if you want to do messaging, then please just use Hazelcast Jet. And you must understand that in that case, again, it's trade-off. If you are using Jet, it will be much faster than Kafka and much easier to set up as well, but Kafka has persistence, whereas we are in memory. So it's Hazelcast Jet. If you use messaging, if you want to send events, it's Jet. That might be interesting to you. So you will connect two endpoints, and one emits events and the other receives it. Yeah, that would be the use case. That you forgot the mic, unfortunately.
I was tricked by the queue structure that we have in Hazelcast. I was using the queue structure.
Yes. Yeah, but as I mentioned, you can use the queue, but then you must have event listeners. We have them, but it will be a lot of manual work.
No, it was camel work. Camel routing. I was using Hazelcast camel. And
Check Jet. Believe me.
now I have Jet.
Other questions?
Please. There you go.
Hello.
Hai, ce faci?
Bine, mulțumesc.
Ce faci, ce puroi?
Happy to be here. Okay, so my question is, how fast the replication happens? What is the impact on the Hazelcast and the caching on memory footprint and CPU?
The answer is always it depends. No, I'm not joking in that case because it depends what you store in the session. I mean, basically what we will be doing is just that we serialize your stuff and like put it somewhere so that it can be replicated. And then you can decide to how many nodes it can be replicated, this kind of stuff. So the memory footprint, it depends. We have an enterprise feature that offers off heap, then it's enterprise.
So it's not always the better to use something like this solution instead of sticky sessions.
The problem is sticky sessions is you must be very, very sure that no node will fail.
Well, if that node fails, you can start a new session on another
Yeah,
node.
but imagine you are in like you are doing e-commerce, and your cart is stored on a node. So this node fails.
Yeah,
You
your
go on
cart is
another
the-
node. You've lost your cart. Do you think any business will be happy with that? No, what you should do is basically, that's what I showed you is like just a demo, but actually you should have like sticky sessions and session replication. And then you get the best of both worlds. I mean, you lose a bit because every time you do stuff, it replicates, so it takes a bit of time, but then mainly you always go to the same node, so it should be very, very fast.
Thank you.
Thank you. Yes.
Hello.
Hey.
One question is the management or the GUI that you showed us is in the free version or just enterprise version?
No, that's what I mentioned. Right now, it's enterprise feature, but we are considering very, very deeply. And when I say that, when they have Oracle stuff, there is this safe harbor statement that you should not believe anything of what they say or base your business decisions on what I'm saying. But
Yeah, it
we-
was a different thing that I understood, closed versus open source. So you said that it's not open source.
we have an open source offering, and then we have like enterprise features. So far, the management center is enterprise, but we are considering very deeply to open source it. So, look for it and wait for it because I believe it's going to be soon.
And instead of the IMAP, can we use the replicated map for both of the features that you showed us? The replicated map doesn't use partitions,
Actually,
and it will be
if-
always
if-
there, the data in the...
That's where I am super lazy, is I didn't care that much about the implementation that was used. Basically, every time I use an abstraction. So I used an abstraction first on Hibernate. I use Hibernate, just configure it, and it worked. And afterward, I use Jcache, and then it worked. And afterwards, I didn't show the code on the last part, but basically, I'm just using a Tomcat Hazelcast manager that I configure in my embedded Spring Boot, and then it works. So I'm using the right structure for what I need to do because basically it has been coded for me. So I don't need to think I should use a queue or a map or whatever. It's just like I use.
Yeah, but the main difference between IMAP and the replicated map is that IMAP has partitions, and if you have 10 nodes, you'll have the data partition all the nodes.
Yes,
so
true.
if you want to get a key, it might be on your local node or it could be on another node. So it could be very fast or...
Yes, but you
to
can have
advance,
near cache as well. So basically you can have like a replication of more data locally. And again, it's a trade-off.
yeah,
So
okay.
check the near cache feature.
Okay, thank you.
Thank you.
Any other questions?
Again. Hi. So I was wondering if there is any alternative to the GUI that you showed us.
Sorry, again?
And should I speak louder?
Yeah, I'm old.
Okay. So is there any alternative to the GUI that you showed us that it comes as a part of open source. Is there any alternative to monitor the synchronization or the status?
You
of
have GMX out of the
Okay.
box, so basically you can open your G console and check your stuff, but it will be less rich. You will have less data, it will be less comfortable to use it.
Okay, thank you.
But you have GMX, and you can implement your own event listener. So basically, if you're interested in certain kind of events that are shown on the GUI, but you want to automate everything, then you can have event listeners, and then you do your whatever you want. I mean, we have a lot of integration points at different levels. So normally, you can do whatever you want. It's just that you will need to work.
Okay, thank you.
Questions? Well,
Thank you very much.
thank you very much, Nicolas.
Thanks.
Your warm applause, please.